In the UK, as an AGT, whether you will be involved in gas testing for confined space entry, for hot work, or in a role as a fire watcher, you must be aware of the relevant sections of the following pieces of legislation. The Health and Safety at Work Act specifies that employers have a duty of care to provide a safe working environment. The Management of Health and Safety at Work regulations outlines the requirement for employers to ensure that risk assessments are carried out, to ensure a safe working environment, and that competent people are appointed to carry out the risk assessment. The Control of Substances Hazardous to Health regulations looks at the various substances that are used in the industry and how these can be eliminated or substituted to reduce the risk to personnel. In the past, many accidents and fatalities have occurred when entering confined spaces, and many countries have now introduced legislation to ensure that the risks of entering and working in confined spaces are reduced to as low as reasonably practicable. If you are to be responsible for gas testing for confined space entry work, you should also be aware of the relevant sections of the Confined Spaces Regulations, which defines the term confined space, the risks that can be found within confined spaces, and the precautions that must be taken and the measures that must be in place before entering and working within confined spaces. In the USA, the Occupational Safety and Health Administration, OSHA, have similar regulations, and many countries have codes of practice relating to gas testing for confined space entry, hot work, and for the role of the fire watcher. As an AGT, you should have a good knowledge of the legislation and codes of practice of the country you are working in. You should also be familiar with your company's operating procedures and reference any manufacturer's instructions that may relate to the confined space that you are about to enter or to the equipment that you are using. When carrying out gas testing for confined space work, as the AGT, you must have a good understanding of your company's confined space entry procedure and safe systems of work to enable work to be carried out safely. The AGT must also be aware of any relevant legislation that may apply for the country where they are working. In particular, the workplace exposure limits for working in atmospheres containing toxic gases or vapors. For gas testing in confined spaces, most procedures and safe systems of work will require a standby person to be appointed. The standby person is responsible for overseeing all confined space entry work, controlling entry to and exit from the confined space, maintaining communication with personnel within the confined space at all times, logging atmospheric gas test results at regular intervals, as prescribed by procedures, checking any gas monitors that have been positioned outside of the confined space, if required, instructing personnel to immediately withdraw from the confined space if an alarm sounds or if the work status changes, and raising the alarm and summoning help in an emergency. Work within a confined space will also require an entry permit to be raised as part of the permit to work system. Entry permits are used to certify that the atmospheric conditions in the space to be entered are acceptable and to document the necessary precautions. As the AGT, you will be responsible for recording the gas test results on the relevant sections of the entry permit and permit to work to prove that the area is safe for work to proceed. It must be remembered that the initial permit to work is for the gas testing only, and a separate permit to work will be required for the tasks to be carried out in the confined space. The confined space must be clean and purged, and ventilation must be provided, which may be mechanized to ensure that there is an adequate supply of fresh air into the space. Mechanical ventilation is essential where portable gas cylinders and diesel-fueled equipment are used inside the space, due to the dangers from a build-up of engine exhaust. Remember, all methods of mechanical ventilation must be earthed. Testing of the atmosphere by an AGT is necessary to check that it is free from both toxic and flammable vapors and that it is fit to breathe. As conditions at the worksite may change, continuous monitoring and retesting of the atmosphere during the work is necessary as a further precaution to ensure that the worksite remains safe. The exact testing, retesting and monitoring requirements for the task will be detailed in the risk assessment, work permit and entry permit. As a minimum, the atmosphere within the space must be retested whenever the space is re-entered by personnel. Continuous monitoring of the atmosphere will normally be carried out by placing a portable gas detector at the worksite, or by one or more member of the work party wearing a personal gas detector. When used, portable gas detectors should always be placed close in the confined space, near to where personnel are working. The AGT will establish communication with the standby person during the gas testing of the confined space. Once the AGT has analysed the atmosphere within the confined space and declared it safe for work to commence, the results will be recorded under the Control of Work system, and the permit to work or work control certificate can be issued for the space to be entered and for work to take place. When work is being carried out, regular communication between personnel inside the space and the standby person must be maintained to ensure safety and to raise the alarm and summon help in the event of an emergency. When carrying out gas testing for hot work, in other words any operation involving naked flames, or producing heat and/or sparks, or any operation that has spark potential, as the AGT, you must have a good understanding of your company's procedures and safe systems of work to enable work to be carried out safely. For all hot work, a supervisor shall be appointed to oversee the work, to ensure that all procedures are followed and work is carried out as safely as possible. Prior to hot work commencing, the AGT will test the area to ensure that the area is free from flammable or combustible materials, and that the atmosphere is safe for work to proceed. Continuous monitoring and retesting of the atmosphere will be required to ensure that the atmosphere remains safe throughout the duration of the work, and that no flammable or toxic substances enter the area as work progresses. As the AGT, you will be responsible for recording the gas test results on the relevant sections of the permit to work to prove that the area is safe for hot work to proceed. For all hot work, a fire watcher will be appointed to observe the work and to monitor the area for any fire potential or ingress of a flammable gas into the vicinity of the hot work area. The fire watcher must stop all work if the work becomes unsafe and report the situation to the central control room. If at any point you come across an issue that cannot be resolved, you should contact your supervisor in the first instance. The AGT will establish full communication with the standby person during the gas testing of the worksite. Once the AGT has declared it safe for work to commence, the results will be recorded under the Control of Work system, and the permit to work or work control certificate can be issued for the hot work to take place. When work is being carried out, regular communication between the work party, the standby person and the fire watcher must be maintained to ensure personnel safety and to raise the alarm and summon help in the event of an emergency. Before carrying out gas testing activities for confined space entry or hot work, a risk assessment must be carried out in order to reduce the risk of injury to personnel. A risk assessment involves identifying the hazards, identifying the personnel who may be harmed and how, evaluating the risks and identifying and implementing precautions or control measures to reduce the risk to a level that is as low as reasonably practicable, a LARP, recording the findings and reviewing the assessment and updating it if necessary. The risk assessment must be suitable and sufficient, which means that you must be able to show that the proper checks are made, all potentially affected personnel are considered, all the significant hazards are dealt with, taking into account the number of people who could be involved. The precautions are reasonable and the remaining risk is low, and personnel doing the work are involved in the risk assessment. Select the links to learn more. For confined space entry, the risk assessment must consider the following: nature of the task, environment and the configuration of the space, means of access and egress, specialized personal protective equipment (PPE), communications, mechanical and electrical isolation of equipment, ventilation and purging, materials, tools and lighting to be used, competency of personnel, and arrangements for rescue. Due to the possibility of changing conditions at the worksite, The risk assessment should be dynamic and continuous throughout the duration of the work, and the atmosphere should be tested continuously throughout the work to ensure a safe working environment. For hot work, the risk assessment must consider the need to continuously monitor the atmosphere and the worksite for changes in conditions. Consideration must be given to the following: removal of flammable materials and residues before work commences, isolation of plant, using a fire watcher to observe the work and raise the alarm in the event of an emergency, specialized personal protective equipment, PPE, suitable tools, equipment and materials to be used for the work, emergency procedures, and location of firefighting equipment. Many of the gases that may be present at your worksite can be flammable or toxic. What do you think are the key things that you must understand as an AGT? Type in your answer and then select Submit. Let's see if you are right. Select the next button to move on. As the AGT, you must understand the risks from the gases and vapors, their potential to cause explosions, and the effects they may have on the human body. It is also essential to understand how gases react in air and where to test the atmosphere to locate gases. As the AGT, you must always risk assess the gas test that you are about to carry out to ensure that the situation remains safe. This is particularly important where you have been asked to test an area where there may be a potential gas leak. Do not rush in and put yourself at risk. Plan the test, assess the risk, and consider what must be done to reduce the risk to a LARP. Most companies have a standard that specifies the minimum items of PPE that must be worn when on site. Typically this includes hard hat, hearing protection, safety glasses, coveralls, gloves, and safety footwear. Before donning the PPE, you should check that it is fit for purpose, and if not, it should be changed out for new equipment. Keeping your PPE clean and storing it appropriately will help to maintain the equipment so that it is always ready for use. For gas testing for work involving confined space entry or hot work, the risk assessment will identify the specialist PPE required to meet the needs of the particular job and to protect personnel from different toxic and flammable gases that may be present. If you have to enter a confined space where hazardous substances may be present to carry out a gas test, the need for additional PPE, such as breathing apparatus, safety harness and buddy line, will be specified on the risk assessment. For hot work, PPE specifically designed for hot work should be provided. The potential for toxic fume emissions from the material being worked on, or surface coatings should be considered, and appropriate steps should be taken to provide for respiratory protection. If in any doubt about the PPE requirements and its condition, contact your supervisor or safety advisor for advice. If you are to carry out gas testing duties in an area that may contain toxic gases, the risk assessment will specify the need for respiratory protective equipment, RPE. There are various types of RPE available, and the risk assessment and your safety advisor will help you to select the type that is most appropriate for the task that you are about to carry out. Remember, cartridge-type RPE, designed for the exclusion of dust from the airway, will offer no protection against toxic gases. For testing in potential toxic gas areas, a positive pressure respirator is recommended. This ensures that if the facepiece becomes loose, the positive air pressure will not allow toxic gas to ingress. Your company may have a policy of no facial hair when using breathing apparatus. You should check this with your supervisor or safety advisor. Before wearing breathing apparatus, your safety advisor will carry out a face fit test. Face fit testing is the method used for checking that a tight-fitting facepiece matches the person's facial features and seals adequately to the wearer's face. It also helps to ensure that poorly fitting facepieces are not selected for use. An inadequate fit will significantly reduce the protection provided to the wearer. Face fit testing can also be used to ensure that an individual knows how to properly put on and wear the respirator. To understand a little more about gases, let's consider how gases react in a normal atmosphere. Relative density is the ratio of the density of a gas compared to that of air. Gases that have a low relative density, such as methane, are lighter than air and will rise under normal conditions. They tend to collect beneath objects or surfaces which prevent them from rising upwards. Gases that have a high relative density, such as pentane, will fall to the ground and will tend to gather in low-lying areas or drains. In practice, other factors such as temperature and pressure will affect relative density gases. Let's learn more about some of the most common gases that are found in the oil and gas industry. Methane has a relative density of 0.55 and is lighter than air. Check high points and areas where the gas could become trapped by structural members. Methane is flammable. Carbon monoxide has a relative density of 0.96, close to the density of air. It will rise but can become buoyant. Carbon monoxide is not flammable, but it does have a toxic effect on humans. Ethane has a relative density of 1.03, close to the density of air. Because ethane has a relative density very close to 1, it stratifies, and it will rise or sink dependent on the turbulence in the area. Ethane is flammable. Hydrogen sulfide has a relative density of 1.17. Hydrogen sulfide can be found at low points or in drains. H2S is flammable and toxic. Propane has a relative density of 1.52. It tends to pool around the leak point and spread out like a liquid. Liquid propane will flash off very quickly at ambient temperatures, forming a huge gas cloud. Propane is flammable. Sulfur dioxide has a relative density of 2.26. Sulfur dioxide can be found at low points and in drains. It is both flammable and toxic. Benzene has a relative density of 2.29. It can be found at low points and in drains. Benzene is highly flammable and carcinogenic. Pentane has a relative density of 2.48. It can be found at low points and in drains. Pentane is highly flammable. A change in temperature at the worksite can change the hazards posed by any gases that are present in the atmosphere. An increase in temperature will generally lead to a reduction in the relative density of gases, causing them to rise and then increase in volume. A decrease in temperature will generally result in an increase in relative density, causing gases to fall or condense, and a reduction in volume. Let's try an exercise to test your knowledge on the characteristics of some of the common gases that you've just looked at. Drag and drop the gases on screen to their correct characteristics. When you're happy with your answers, select the Submit button. Well done! That's correct!